Have you ever wondered if going to college actually inflates lifetime earnings? It's clear that people who go to college tend to earn more, but that doesn't mean college is a cause. People who go to college, compared to those who do not, might come from family support and intergenerational wealth, may benefit from generous support systems, have been better prepared for school. So the question is, does college actually make you more money? Or is any associated increase in earnings exactly kind of increase we would expect over time, regardless of college participation? Asked another way, is the difference in salary between those who do and those who do not attend college any different before and after college attendance? Although the gold standard is to run an experiment that randomly assigns people going or not going to college, such experiments are infeasible and may not be ethical. Thus, we have to work with observational data using econometric analysis. To figure this out, empirists use a method called difference in differences. This method literally asks, is there a difference in the difference that we had earlier observed? It does so by considering distinctions between groups before and after points in time synonymous with events of interest, like college attendance. Suppose that in 2015, a new state policy cut college tuition fees in half for students. Students in Town A benefited from this policy, and hence they're the treatment group. Town B doesn't have such policy as it belongs to a different state. So tuition stayed the same, and they're the control group. We're interested in whether this tuition reduction leads to changes in individual earnings, holding other factors constant. We follow high school graduates in both towns before and after the policy was put in place. Before the policy, the average annual earnings of people in Town A were around $34,000, and in Town B were around $32,000. But after the policy was put into place in Town A, the average annual earnings in Town A went up to $44,000, while in Town B, they went up to $36,000. So the additional income boost that Town A saw was $10,000, while Town B experienced an increase of $4,000. The $6,000, 10,000 minus $4,000, is called difference in differences. One key assumption for DID is the parallel trends. This is a measure of whether these income trajectories would have been similar without the policy, so-called parallel trends. In other words, if we believe that Town A and Town B would have followed the parallel trends, if not for the policy, then the extra $6,000 boost in Town A is a credible estimate of the policy's impact. The beauty of DID lies in and it relies on the validity of the parallel trends assumption, which could be empirically tested by data. We love DID because it does not require the treatment group and control group to start at the same level, but only requires a difference in the group differences evolve similarly prior to the treatment. This helps us figure out how things like college access affect earnings. Even if we couldn't randomly assign people to different groups, we can still use DID when experiments are not possible because some exogenous shocks can serve as quasi-natural experiments. If you are interested, please follow Yu Fei Shen's micro video for the lecture of staggered DID.